In this lecture, we're going to look at some normalization examples using the same functional dependency exercises that we have looked at for functional dependencies, partial dependencies, and transitive dependencies. We're going to look how to go ahead and set up these relations to third and Boyce-Codd normal form. So looking at our first example, our parts example, note that I have eliminated any transitive and partial dependencies. So when you're setting up your functional dependencies, when you're identifying your functional dependencies, if you eliminate those partial and transitive dependencies right off the bat, you're already putting yourself well into the normalization process. Since we've eliminated partial dependencies and transitive dependencies, we are already in third normal form with our functional dependencies. All we have to do is convert those to relations or tables. So what we will do is take each functional dependency, part number and description, and create a table out of it. So we put those attributes down here and bring down the values for each of those attributes. Note that we're eliminating this duplication or redundancy that we have where logic chip and part number exists twice and memory chip and its part number exists 3 times. So we just bring it down once, eliminating that redundancy. And our second functional dependency is vendor name determining address. So we bring vendor name down and address down, pull in the distinct values for vendor name and address, eliminating duplication that's no longer necessary. And finally, our final functional dependency is part number and vendor name determining unit cost. So we bring part number, vendor name, and unit cost down and bring down those distinct values. Now, note we do have some duplication in the vendor name table here, but vendor name is part of our primary key. Notice that I've underlined all of our primary keys in each of our tables to help you identify those. So if an item is part of a primary key, especially if it's part of a compound primary key, and I guess more so if it is part of a compound primary key, it's okay to have duplication in one of those values, just as long as it's not duplicated across both values together. So we don't want 1, 2, 3, 4 and fast chips occurring twice. But 1, 2, 3, 4 fast chips, 1, 2, 3, 4 smart chips, that's okay. We have smart chips duplicated here, but with 2 different part numbers. We have the part number duplicated here, but with 2 different vendors. For example, in our part table, our part number, where that only has 1 primary key, we don't want to see 1, 2, 3, 4 in there twice. That's unnecessary duplication, and it breaks the rule of a primary key having to be unique. So at this point, we are already in third normal form. We just need to check for Boyce-Codd normal form. In order to achieve Boyce-Codd normal form, we need to eliminate any insert, update, deletion anomalies due to redundancy. We don't have any redundancy in the sample data set we were given. If, for example, we had another vendor in Cupertino, it might make sense to move address out into its own table, create an ID for that, and leave that behind. But given this sample data set, we've normalized it to Boyce-Codd normal form at this point. Okay, let's take a look at our next example. Again, we've eliminated any partial dependencies and any transitive dependencies that exist within our functional dependencies. So the functional dependencies we have listed, once again, already have us at third normal form. So all we have to do is convert these to a relation. So we take our first functional dependency, student ID or STID, determining last name, first name, phone number, state license, and license number, and bring those down as attributes for our first relation or table, and bring down the appropriate values. Note that we're eliminating the duplication that exists in the upper relation. So we just have 2 records, one for each of the students listed in the above relation. Then we take a look at another functional dependency, the ticket number determining date, code, and student ID. Bring those attributes down. Note once again that I'm underlining the primary keys, and we bring down the unique values for each of those. I'd also like you to note that I am italicizing foreign keys in these tables just to point those out to you. So STID is a foreign key pointing to STID in this what I would call a student table above. That'll become important when we look at the next step, converting the normalized tables to ER diagrams. And finally, our third functional dependency is code determining fine. So we bring those attributes down, bring back the distinct values down from up here. Note that we don't duplicate the 1 or the 2. We just bring each of those down once and their corresponding fine value. So now we have all 3 of these in third normal form. Now, again, to get to Boyce-Codd normal form, we want to eliminate those insert, update, and deletion anomalies that are due to redundancy in the same field. Looking at this, we don't really have redundancy other than, for example, student ID, but it's okay to have redundancy in foreign keys. They're creating your relationship to another table. A place where redundancy could exist is this state license. So if you had another student from Florida, you could end up with some redundancy there. And phone number. If you have 2 students going to the college, that are siblings, you could have the same phone number listed for them possibly if they're living at home. So those would be areas where you might want to break those particular attributes out into their own tables or relations to eliminate that redundancy that would occur if that phone number, for example, were to change or they were to change states. So to do that, how we would handle that is come over here and we would create a state ID attribute and a ST license attribute. Give it a value of 1 for Florida, 2 for Alabama. And I'm just going to go ahead and put a border on this so it matches the formatting of the rest of this. Make those bold and underline that as my primary key. So then we would come back and change the attribute that we've moved into a new relation to remove any redundancy and put in the ID instead. So we changed that attribute to state ID instead of ST license and put a 1 there and a 2 there. This way, if you add another student and need to add someone for Florida, you just put a 1 in there instead. That way, say you go back and decide you don't want abbreviations, you want to spell Florida out. You only have to update that value in one location, in this state field under its particular row for Florida. Without doing that, you would have to update that value in every single record it existed in the student table. So that's where you get into an update anomaly, where you've got to update the same value in multiple locations. And again, with phone number, if you were concerned with redundancy there, we could break that out into its own table. Phone ID and phone number. Bring those values in. I'm just going to use a different ID range here just so it's a little more identifiable. Add a border around these to match our formatting. Make the field names bold. Underline our primary key. So again, when you're doing your Boyce-Codd normal form, you're going to remove that attribute out into its own table or relation, come back to the original table, put in the primary key of the new relation you've created, and the primary key values that correspond with the values of that existing attribute. So now if we have 2 siblings sharing the same phone number and their phone number changes, you're able to just update that in one location. Okay, let's move on to our sales example. So once again, we have eliminated all partial and transitive dependencies from our functional dependencies, and we just need to convert these to relations. So we take our first functional dependency, POS, determining zone, bring down POS and zone as attributes for our new relation or table, and bring down the distinct or unique values for each of those records. So we have the 3 POSs in this data set, 123A, 456B, and 789C, and their corresponding zones. We look at our next functional dependency, which is agent determining POS. So we have agent down here and our POS attribute, and bring down our distinct values that show which POS each agent works with. And finally, our last functional dependency, agent and product code determining quantity sold. We bring in each of those attributes and the distinct values corresponding to each of those. Note again, I have underlined each of our primary keys and italicized the foreign keys. So POS here is a foreign key linking back to POS in this particular table. Agent here is a primary key, but it's also a foreign key linking back to the agent in this particular table. All right, that concludes this look at normalization. You could, taking this to Boyce Codd normal form before I wrap up, you may move zone out into its own relation. So you could create a zone table with a zone ID and zone. So 1, 2, 3, zone 1, zone 2. I guess we only have 2 zones. Format that to match. Make that bold. Underline our primary key, then come back, drop in our ID and the appropriate ID values that correspond to each of those zones. And that will allow you to achieve Boyce Codd normal form for this particular example. Okay, so that wraps up this look at normalization. Once we've gone through our functional dependencies, eliminated our partial and transitive dependencies, that gets us right to third normal form. Then all we have to do is be concerned with any redundancy in non-key fields. So you don't want redundancy in typical attributes. If it's a foreign key, it's okay to have redundancy there. But any other attributes shouldn't have redundancy in them where appropriate. To handle those, you break those out into their own table or relation, add an ID field, drop the ID and associated values for each of the attribute values for each record into your existing table, and that gets you to Boyce Codd normal form. If you have any questions on the normalization process, functional dependencies, partial dependencies, transitive dependencies, and normalization, please contact me via one of the methods in the syllabus. Thank you.